Okay, yeah. Yeah, good morning. Welcome to my YouTube channel, Nautically 101. So, this is my very first video. So, I would really appreciate if you hit that subscribe button and also click on the bell icon so that as soon as I post a new video, you'll follow up. So, this page is specially dedicated for seafarers, navigators, marine engineers, and maritime experts who want to expand their knowledge. I will be dealing on different subjects and topics. It will range from navigation, celestial and coastal navigation, maritime or admiralty law, ship business, and cargo handling, ship stability and structure, and it's going to be general. Trust me, it's going to be a generic knowledge about maritime. So I'm your guy. I'm your plug for this. So thank you very much. So for a start, I'm going to be treating this question on the board now, and it's a question on position arrived using the mercator selling. And why I'm going to start with this is because mercator selling is very important because you use it to cover a long distance. When you're considering a long distance in all of the run line selling, you use mercator selling. So based on that, I'm going to do this first video I'm dropping is going to be on arrival position, and afterwards I will give you another one on course and distance. So we're just going to go straight, gentlemen. So the question says, using mercator method, find the position arrived when a vessel in position. This is the latitude 0958, 09 degrees, sorry, 09 degrees, 58 minutes, and longitude 005 degrees, 12 minutes west. Bring me a calculator. So, and she sailed a distance of 1,128 with a cost of 229.7. Oh, thank you. So, I'm going to go straight. I've drawn this compass on the board just to give you, because it's ideal that you convert this cost, okay, so that you know exactly what you're working with. And this is 229.7. This is 0 degrees, 90, 180, 270. So it means that 229 degrees is somewhere here. So we'll say this is 229.7 degrees true. So and it means that this man has covered here, here, and additionally here. So what you're going to do is to convert it, and this is a southwesterly direction. Please, it's southwesterly direction. So what you're going to do now is you will convert this by subtracting 180. So we're going to say, I'm trying to conserve space, okay? So 229 minus 180 degrees. 229.7 minus 180, you use your calculator, and this is 229.7 minus 180. So you have this calculator is okay. 229.7 minus 180. Okay, so we have 49.7. 49. So it's south, 49.7 west. Sorry, I'm trying to economize the board. So what we have, if you subtract 229.7, subtract 180 from it, we have south, 49.7 west. And I'm going to go straight to the business. And what I'll do is this is the formula. First of all, I'll give you the formula here. The formula is Lat, first of all, is equal to, not Lat, sorry. tan theta. And d lat is equal to distance cos theta. Okay? So this is your basically the formula we're going to use to solve everything. So let's go ahead and so now we'll find d lat first of all. First we'll find d lat, and from this d lat is equal to our distance was given as 1128, okay, and cos theta. Cos theta, the theta is the cos, so it is 49.7. Okay, so when I've done this, you use your calculator, because I always advise you use the calculator, but you can use the table to do this. But for the sake of if you're doing an exam, a competency exam, you need to be very fast. So you have to use your calculator until you get to the part where you need to find DMP. Then you must go to the table, though there is a formula for DMP, but at the end of the formula, but I advise that you should use the tables for the DMP so that you have a correct reading for that year. Okay, so we have 1128 cos 49.7 degrees. Okay, so we have, please, I want you to follow up because I will not be writing everything. So what we have here is you see the figure I have here. Okay, it's not clear. Okay, it's 729.57888, but now you need to work in degrees because you're looking for a d lat. It has to be in degrees. So you're going to divide what you have gotten when you punch this. What you've gotten, you divide it by 60, and now you have it in degrees. So we have 12 degrees, 09 point 34.73. You have to divide by 60 as well, and we have 0.5, or call it 0.6 approximately a minute. So now, to name your d lat, you use this as a guide. That is why in the first place I tried to calculate the cost to bring it to a quotation where it's compatible. So we have southwest. So you have to name this south. Okay? You have to name this south. All right? And this is not necessary. So you name it south. So your d lat is equal to 12 degrees 09.6 south. Okay, and you have been given an initial latitude of 09 degrees 58 minutes is 58.0 anyway, north. Okay, and this is a initial lat. Okay, so what you do here, because it is it's different names. It is different names. Please take note. If you're trying to find a final lat from your d lat, if it's the same name, you add. For different names, you subtract. But it's the opposite when you have arrival and initial latitudes. If you have arrival and initial latitude, you do the opposite of what we are doing now. And that's what we apply when we're going to find the difference in meridional parts. That is the DMP. So, so this we have to subtract, okay? So we'll subtract 12 degrees 09.6, okay, from 09 degrees 58.0. So, and we have 02 degrees 11.6 minutes. So this is your final. Oh, sorry, Starbucks. It's my guy. Yeah. Okay, final lat or arrival lat. Okay. So your final lat becomes 02 degrees 11.6, and now you have to name after the big name. All right. Always name after the big name, and we have south. Okay. So this is our arrival latitude. Now we have found our arrival latitude. The next thing, I think I have to conserve the space, so I'm going to divide this board a little, and I will minimize my handwriting. Okay, so now the next thing is to find the meridional parts, because we need to find the DMP, and we use the initial lat and the final lat to find the DMP. So I call it MP1, MP2, and then finally DMP. Okay. So straight to the our big book. So we'll go to the section where you find information about the meridional parts of spheroids. Meridional parts of the terrestrial spheroids. Here is it. Okay? And you see on the top you have the degrees. You only have meridional parts for latitudes only. Please take note of this. There is no meridional part for longitude, so you don't play around. Okay, so these are the degrees, and this is where you find the minutes, degrees and minutes. Okay, so and in this question we have 12 degrees and sorry, not 12 degrees, 09 degrees was the initial lat. 12 degrees is our D lat. Yeah, so we have 09 degrees. Please, it's always initial and final latitude. Do not find meridional parts using your D lat. D lat has no business with the DMP. So we're going to use our initial latitude, which was given in the question. And so the initial lat is 09 degrees 11, no, it's 09 degrees 58 minutes. So you're going to walk all the way on the big book. This is 09 degrees, and 09 degrees on 58 is somewhere here. Okay, I'm just giving you as a guide. So let me come closer. So you see, this is 9 degrees and 58. So you work it under. See, this is the figure. So it's 597.0. Okay. So from the knowledge table, our MP1 is 597.0. Okay. Next is the final latitude we got. We have 02 degrees and 11. So you go back and check again. Under 2 degrees 11. Can you see that? This is 2 degrees and this is 11. So it's 130.1. Okay? So we have MP2 130.1. Okay. And then like I told you, what you've done here is, because you're trying to find the final latitude from the D lat. But now we have, this is our latitude 1 and latitude 2. Okay, so what you do is you apply the principle when you want to convert to D lat. Okay, so now what we do in this case, because they have different names, you add. Okay, if it's the same name, you subtract. That is the rule. So we're going to add 597.0 plus 130.1. Okay, and It gives us 727.1. Okay, and then we are ready to work on the formula number 2. This is the next formula, and we're going to work on this one. So we're going to find D long. This question just requires you to find the D lat and D long. That's the arrival position. Position arrived. So we go straight up, and we now have the formula is okay. I think I can take this off. Let me have a rag. Yeah, give me a rag. Give me a rag. Okay, so I can take this off. Don't mind me, I'm using a prominent marker. I've used a permanent marker, so it's a little bit difficult to get off. Okay, so this is fair enough. Okay. Okay, so here we go. So we have this formula. I can bring it over here. The formula D long is equal to DMP tan theta. Okay? We know this is multiply. It's times. All is times, times, times. Okay. So, and we know our DMP and we know theta already. So we're going straight. D long is equal to 727.1 times 10 49.7. So we're going to go straight. I told you the essence of using the calculator is for speed, because in an exam you need to be very fast, and nobody is going to fail you when you've used the calculator, just as they will also pass you when you've used the table. You use the logarithm table, but this case it's not a problem. So 727.1 times 10 49.7. Okay, and we have another big figure, 857.3668912. So we go again, we divide by 60. Divide it by 60, and it gives you the final figure. So we have D long is equal to 14 degrees, 17 point, so we have 22.01 divided by 6. So it's 22 points, we can call it 22.4 if you approximate minutes. Okay, now remember it's a southwest direction. It's going to be west. Okay, then you bring your initial longitude, initial long, and then we have an initial long of, sorry, you add 0 because this is longitude. Longitude is a three figure, okay, 3-figure notation. So we have 005 degrees 12.0, okay, west. It's same name. So what you do to the same name is you add, okay? Like I said before, you add, but you do the opposite when you're converting to D long. For example, when we find the final longitude and you want to apply the 2, you want to bring it back to D long, to this D long, you're going to add, okay? Sorry, not add, you're going to subtract rather. You subtract. This case, you have to, because they bear the same name, you add, because it's a D long and initial long. But in the case of you have initial long and final long, and they are bearing the same name, you subtract. Okay, so what we're doing here is we're going to add, and we have 014 degrees 17.4 minutes plus 005 degrees 12.0. It's 0. So it gives us 019 degrees 29.4 minutes west. Okay, so this is the final long, final longitude. Please, this when I say final, I mean the arrival longitude. So the answer to this question is the vessel departed latitude 0958.00512 west, and she has arrived latitude 02 degrees 11.6 and longitude 019 degrees 29.4 west. Okay, so guys, I think this is good enough. Thank you very much, and please don't forget to hit that subscribe button. Thank you. See you on the next video. Thank you.